Okay, welcome to the 23rd session of the Hawaii iOS Developer Meetup. What's going on, Tyler? Quote of the week today is from Steve Wozniak. I hope you're as lucky as I am. The world needs inventors, great ones. You can be one. If you love what you do and are willing to do what it really takes, it's within your reach. And it'll be worth every minute you spend alone at night thinking and thinking about what it is you want to design or build. It'll be worth it, I promise. That was a pretty cool quote. Upcoming meetups. So next week we're going to be covering Bluetooth. I'm not really sure how to pronounce that. Does anyone? MiFi?
Yeah, MiFi.
MiFi.
Like Wi-Fi, MiFi,
Nice.
whatever Fi.
So we'll be covering Bluetooth game controllers next week. Pro tip I wanted to showcase today is, have you ever done diff comparisons within Xcode? It's pretty cool.
I should try that.
I'm just going to show this real quick. So I was coding last night and we were trying to figure out who was to blame for a certain thing. So
I'm to blame.
A cool thing is you can bring up, so you know how you have the usual, you can check out the regular standard editor, the assistant, so you can see them side by side.
Oh, yeah.
This one you actually get to see like
The
Git stuff.
Oh, yeah.
So you can do comparisons between files, different versions. And then the last thing I'm going to showcase is that right down here,
The blame game.
you can actually, the blame game, you can actually pick different branches to compare. And then you can also pick different commits. So this came in pretty handy last night.
Oh yeah, because of in case you guys mess something up.
Yeah.
It happens.
So that was the pro tip I wanted to share tonight. So we'll get into housekeeping. So this Hawaii iOS Developer Meetup, we keep all of our communications on the Meetup page. We're very lucky to be hosted here at HICapacity. If you're interested in becoming a member, you can go to the HICapacity.org membership page. The bathroom is outside and to the right, and the key is on the black lanyard right there. Free tools, I'm going to blitz through these real quick. Spectacle app is great for window management, and Screen Hero is really good for pair programming. The agenda tonight is introductions, and then Adam Smith is going to be doing a talk on core data. So we're streaming this. A couple of developers couldn't attend tonight, so they might be in right now checking it out. So to give Adam maximum time, we're just going to do the introductions real quick. So does anyone want to go first? All right, Tal.
I'm Tani. I'm here, and I'm just learning Swift as a hobby.
Cool. All right. Anyone want to go next?
Sure, yeah. I'm Adam. I'm a full-time iOS developer, and I work in both Objective-C and Swift, but really enjoy Swift more.
Right.
Yeah.
Me too.
All right.
I'm Che. I'm a app developer. The product I'm building, EcoCube, was built in Swift from and several migration to the most recent version. So it's been working 3 years on this project.
All right.
Adil, starting out, messing around with Swift, learning a lot.
Good. Cool. James, you want to
Yeah,
introduce?
sure. James, I run a small development shop downtown called Slickage Studios, and we have a few projects that do native iOS, and we have a Swift project now, so it's been working with things like core animation, things like that, so it's good fun.
It's fun.
Right on. I'm David, the organizer of the Hawaii iOS Developer Meetup, originally from this valley, and I'm really happy that you guys are here. I'm really excited about your talk, Adam, and we're just ready to dive right into it. So
Okay.
feel free to just hop
Dive
in.
in.
Grab my chair over here.
Can you help me find the presentation?
Oh, sure. So it's going to be on this monitor right here.
Okay, sweet. Okay, so we're going to talk about persisting data in iOS. And it's kind of a big topic. It's a huge topic. How do I make this thing full screen? Does anybody see it?
Is it present all the way on the top?
There it is. Yep. Although okay. Well, you guys can see it. So
Yeah.
basically, persisting data in iOS means if you create an app and you put some piece of data, create some piece of data, it'll stay there as long as the view controller, if it's in a view controller, it'll stay there as long as that's in memory.
Yeah.
That includes if you go to the background and you come back and iOS didn't shut you down, it will remain there. But if you want to be able to hard close the app, or if the system hard closes the app, and you want to retain that data, you want to keep it on your device, you need to persist it. And there's several different strategies for persisting your data. And they all have their different places. That's what we're really going to talk about tonight. We're going to go relatively fast through the first three so you can hear about them. And then the fourth one is the main topic for discussions. We have user defaults, keychain, NS-keyed archiver, and core data. So, okay. So user defaults is, it's like the simplest data you want to store. So if you want to store something like, has this user ever opened the app before? You would set a bool in your NS user defaults and you'd say yes or no. If you want to say their favorite color, right? Something really simple, you might save that in user defaults. It's nothing complicated, no large objects, but really simple things like that. And here's the API for it. It's very simple to use. There's a singleton, so that's user default is the class. Standard is the singleton instance of it, and then you just set it. So you set the string dog, and it's for a key. So you have a bunch of keys. So if you have a preference of pets, cats or dogs, you would save that like this. The user picks dog, and you would call this function. You'd say set dog for key pet preference. And if you come back later and you want to get that information out, you can create a pet preference, and you say, give me what is the string for the key pet preference. Now, if you close your app, if you the system closes it for you, and you come back later, that's no problem. This will still be here. Okay. So this is when you would use user defaults. The pros are it's really easy to use. That is the whole API I just showed you guys. The cons are is it's not really secure. So if a hacker were to get a hold of the device, they could potentially get access to that information pretty easily. You can't really model objects very well. It's good for little pieces of data. And feel free to stop me if there's anything that's not clear. Yeah, please.
So then for user default, what's probably the best use case? I'm thinking maybe like settings. If you're doing, like,
settings.
Is there any other like use case?
Settings. Sometimes people show a welcome walkthrough tutorial the first time you ever open an app. Has user opened app is a bool. You can save a bool, and that's a great use for NS user default.
Yeah.
Okay.
And it's the first time they watch that walkthrough, you set that default to has watched, and then next time you check when the app opens, has user opened the app before? Yes, they have. So skip that tutorial.
Exactly.
Okay. Thank you.
Sure. The next one up the ladder is keychain, and keychain is basically NS user defaults with encryption. It's the type of thing where you don't want to store, again, you don't want to store model objects. You really want to store things like passwords, tokens, things that you wouldn't want a hacker to get a hold of if they got into the device.
Yep.
But it's the same kind of things. It's like simple things like strings, like passwords, usernames, tokens, things like that aren't complex models. But the default implementation, if you just go use Apple's API, it's very, very complicated, right? You would never use the default implementation. So there's a couple of different wrappers. The ones I've used, they're all pretty much the same. Swift keychain wrapper is something that I recommend, and it basically turns the API into something that's almost the same as NS user defaults. So you use pretty much the same thing.
It's a wrapper to the key.
It's a wrapper to keychain. Yeah. It wouldn't really make sense to use keychain by itself the way it's currently set up. So again, the pros are that it's secure, a complex API, and also anytime you have to use anybody else's third-party framework, you open yourself up to risk, like they screwed up or whatever.
Yeah.
So that's one of the cons of using this. But there's not a lot of other options, right? If you want to encrypt that data. So the next one is called NS-keyed archiver. And this gives you a way to persist your model. And what that means is if you have, rather than just keeping strings around or bools saying whether someone's opened the thing or not, if you have a dog model and the dog has a name and a tail length and a bool that says is Shaggy, you could technically create that in NS user defaults. Like you could store all three of those properties and then you could kind of put them together and make a model, but that's not really the right use for it. You want to use this thing called NS-keyed archiver. I wish I could make this bigger for you guys.
No, this is good.
You can see it? Can everybody see it okay?
Yeah.
Command
Yeah.
plus. Oh, command.
Quiet coder.
Like, how do I make that full screen on here? That's what's confusing me. So, here. That's not really helping. How's that? Yeah, there we go. Great, fantastic.
Yeah.
So this is an example, right? If we have a really common thing is you have something like a customer, right? And this is simplified, but a customer would have an ID and a name. And if we want to create a customer in your app and to be able to store it and want it to be there if the app hard closed or, you know, whatever happened, we're going to use this tool to create a simple object persistence. So the way you do it is you have an initializer, and then you have two, so then it has to conform to NS coding. That's the protocol that makes this happen. So you have an encode with coder down here. So this means when you want to save this thing to disk, you want to save your customer, you basically save the different properties and the keys. So basically you just use the same name as the property for your key, and then you take the value there. So if it's Bob Smith, number 2, you just put that information in and you call encode with coder. When you want to come get this information out later, you want to decode your object, you use this convenience initializer here, and decode with coder pulls that information out of storage. So the app hard closed, you want to recreate this customer, you call this initializer and you just decode the object. Does anybody have any questions on that? Okay.
Just a broad question. So NS coder, what does that? I mean, what does it give you?
This tells the system that if your object, in this case a customer, conforms to NS coding, then you can save it to disk. You can persist it.
Yeah.
Otherwise, it won't know that it can call these two methods.
Okay.
A couple things for people that, like we talked, this ties into 2 weeks ago talked with value types versus reference types. As of right now, as of Swift 3, anything that conforms to NS coding has to also be an NS object, so it has to be a class.
Yes.
So that means that we have to go with the reference, it has to be a reference type.
Yeah.
For now, this is going to change, and we'll get to that in a little bit. Let's see, keychain. And so this is what it looks like, right? So we have a customer. We're going to create a customer object, nothing fancy, just like you would normally do. And because this customer conforms to NS coding, we can say, here's the API, NS keyed archiver, archive root object, customer. And then you give it a file path where you want to save it to. That's all you've got to do. This is just a dummy thing. You'd actually want to get a reference to a real file path, but it's pretty simple, right?
Yeah.
And since arrays and dictionaries already conform to NS coding, if you have an array of customers, you can call archive root object on the array of customers. So if everything down the stack conforms to NS coding, you can save a whole tree of things. So it'll know how to do that. It just knows how to do it.
I see.
So by just giving it just the array,
So
or do you have to iterate through the whole array?
no, it'll take care of it for you.
Okay.
So you just take the top level object, right? And if everything in that array conforms to NS coding, right? So in this case, it's only customers. You just go, actually, we'll get to it, but yeah, actually, we'll get to it in a second. So if you want to pull out a customer, so, all right, give me Frank, and we just call NS keyed archiver unarchive object, and you pass in the path that we put in over here, and then you can downcast it as a customer. And then we have a reference to that customer again. This is how we pull it back out. Then we can create another customer, and then we can call archive root object on an array of customers here. And because arrays conform to NS coding and customers conform to NS coding, it's cool, we can do this.
Yeah.
So this is a lot easier than core data. Okay, this is like, let's look at the pros and cons here. So it's really easy. You just put some boilerplate code into your class. It's lightweight. In a lot of cases, if you're not doing anything complex, like with querying and filtering, this is all you need to do. don't even bother getting into core data. So and obviously the cons are you can't query, there's no relationships, so you can't say like give me the customer's bank because it doesn't know how to do that. Okay, and what's really nice and makes this even more likely to use is in Swift 4, NS coding is going to be pretty much baked in. So any struct even is going to be able to
Yeah, I was reading about that.
yeah, you can just basically any struct with relatively simple variables like strings or ints or other structs, you can just call NS keyed archiver on those things starting in Swift 4. So it's even more more of a reason to use this coming up because you don't even have to do all that boilerplate setup that we did earlier.
Yeah.
So
Yeah, I read that on Monday when I got the, yeah, I was looking at that.
for me, that's probably the most exciting feature of Swift 4 right now. And then,
Yeah.
so finally, so I would say when you're thinking about your problem, you want to kind of go through these levels of complexity. Like if it's super simple, if it's a yes or no, let's put it in user defaults. If it's super simple and it need to be secure, let's use the keychain manager. If it's just an object or an array of like relatively dumb objects, let's use the archiving. And then the final in the level of complexity is core data. So Apple says this is their object graph management and persistence. For me, I never use it unless you have to do persistence. Like I never really understood why people would use this just in place of like a struct. But that's Apple's recommendation. That's at least what's in their guidelines. But we're going to talk about it tonight mainly in reference to persisting things.
Yeah.
Sorry,
So-
yeah,
another quick question
please.
about the NSK before we dive
Yeah.
into it. So I remember reading somewhere, and I just didn't understand really well. So I guess with NSK archiver, you either have to like encode everything and like decode everything. So if you want to change, which what I understood, like if you want to change, let's say for example, the last name of one of the customers, you have to decode everything in order to be able to like change just that one customer last name and
Right.
then recode everything,
Yeah.
or did I get that wrong?
No, you got that
Okay.
absolutely right.
Right.
So if you're just encoding a customer, right, and then you want to change the customer's ID, you decode the customer from the file system, you change their ID, and then you encode it again.
Yeah, green code, yeah.
If you have 1,000 customers and you want to change customer 117 and they're all in an array, you actually decode all 1,000, pull out 117, change his ID, put it back in the array, encode the whole thing again. It doesn't seem efficient, but it's pretty fast. Like I've never run into any performance problems with it.
Okay. So even if you have an array with a lot of like
Yeah.
objects in it,
And
so
you might want to measure it. Like if it starts to be slow, that might be a case to use core data. Because core data, you can say, give me number 117, change that thing, and then put it back. But core data is pretty heavy, right? There's a lot of things that make it relatively slow. So there's always these, for me, unless you're doing something super hardcore, you always want to do what's easiest.
Yeah.
Performance things. And then if you hit a performance bottleneck, like it's a little glitchy, then you start to say, okay, what can I do to like enhance this a little bit?
yeah. Thank you.
Yeah, sure. So core data is a framework used to manage the model layer objects in your application. Again, cats and dogs, customers and banks. It has generalized and automated solutions to common tasks associated with the lifecycle and object graph management, including persistence. So for an example, if you want to display in a table view a bunch of cute dogs named Duke, sorted by their bark volume, who are not huskies, you wouldn't want to use NSKeyed archiver. Because you'd want to use core data, because core data allows you to literally drill into that kind of a level and make a query based on that. So the first time you see this graph, I mean, the problem with core data is it's a little hard to understand the first time you're thinking about it, but I'm going to do my best to walk you through all the pieces of this puzzle. So managed objects up here is where we're going to start. A managed object is just an object, like a customer or a dog, managed by the core data system. Okay? The managed object context is just the container that your objects live in.
Right.
And these objects won't know about anything that aren't in this context. So a context is just a container that wraps a bunch of objects.
Right.
For most of our applications, you're just going to have one context. For more advanced things, you can have several contexts. But for now, for tonight, we can just think about your app having one context where your objects live in. And they can be different types. They can be dogs, cats, banks, and customers are different types of managed objects, and they all can live in the same context. Now, so your context, okay, so then we had this idea of a persistent store coordinator, okay? And what this means is this thing coordinates the storage and the retrieval of your objects.
Yeah.
Almost always, you're going to use a database, and the database you use is SQLite. There's other options. You can use things like XML. You can do it in-memory storage, but almost always, I've never seen anyone use anything besides SQLite.
Yeah.
Okay, but it could be other things. I'm sure there's reasons for it. I just don't know what they are. So your persistent store coordinator manages the persistence between to your managed object context and to you using the app when you get your cats and your dogs. You don't care if it's XML or SQLite or whatever. You just want to know, give me my dogs. So you tell the persistent store coordinator, give me my dogs. And this thing has the knowledge of what is the backing store. Like where is it being stored?
Yeah.
But these days you set up the boilerplate code to get all this stuff going, and you just put in the sensible defaults, and it's just going to go and get it for you. So there's never any like SQL commands. You just say, hey, persistent store coordinator, give me my dogs. I don't care where they come from, and it'll hand them to you. All right. So you have your objects, the context that they live in, the persistent store coordinator, which goes and fetches those things and stores those things for you. And we're going to go into those different pieces. So a data model. A data model is different than an entity. So a data model is basically like the place where you store different entities, where you have your cats and your dogs and your customers. An entity represents a piece of data, like a dog. So you can have like your dogs and your cats as part of your model. Each entity has attributes such as max bark volume and name. So an entity has attributes, and an entity can have relationships, like a customer can have a bank. So you can have relationships between models. And this is in Xcode, this is what a model looks like. So you create something called an XC data model D.
I love that name.
Yeah, it's a horrible name.
Yes, given.
But you put your entities inside of your model. So we have a dog and a breed in this example. And a dog has a max bark volume and a name and a relationship to a breed. This is like the visual editor that Xcode gives you to manage your model. And we'll do an example in a little bit, and we'll make one. And now we have NS managed objects. So this is the thing we saw at the top where we had a bunch of model managed objects inside of the context. We can have a dog, which is a subclass of NS managed object, and it has variables, right? We have bark volume and name, and they have to be variables. They can't be let constants because I don't know exactly why, but you have to do it that way. And what you do is you prepend this at NS manage, so the core data system knows that it's responsible for managing these attributes.
Right.
And as we said before, a managed object lives inside of a context. Mm-hmm. So now we're going to talk about a context. Okay, I know we're going fast. Where have I lost people so far? Is there any questions right now?
I have one question in my head. So just inside of core data, can you store like structs and enums, or is it just objects?
Just subclasses of NS managed object, which are subclasses of NS object. So only classes.
But you mentioned maybe in Swift 4 they might be.
No, that's only for NS coding.
Okay.
So NS coding will be like by default in Swift 4.
Okay.
But totally separate from core data.
Yeah,
Okay.
it's a whole.
Anybody else have any questions?
So I know like whenever you do the use core data, it creates two. I don't know if I'm explaining what I'm talking about. It creates two files, right? So is one the object and the other one the context?
We'll get to that.
Okay.
Yep.
I'll
Yeah, it's better to for him to show.
Yep.
Yeah.
So then we have our context, and a context is responsible for keeping track of all the dogs inside of it, all the model objects. That's its job. So when you want to add a dog and persist it, or you want to delete it or modify it, you use the context. To this dog, a context is its entire universe. So it doesn't know about anything outside of its universe. It only knows about what's in the context. And you can have multiple contexts, as we talked about, but usually we're just going to have one. And a context connects to a persistent store coordinator. Okay. So this is our cute dog context. And currently we have 4 cute dogs inside of our context, which have already been stored. And we want to insert a cute dog. So we say we created this and we added a name and an ID, and we want to insert it and persist it. What we do is we say, hey, context, I'm going to insert my dog. Okay, so this is how the API works. And with the persistent store coordinator, this coordinates between that context and the persistent store itself, whether it be XML or SQLite. And when you set up the stack, which as of iOS 10, setting up the stack is easy to do. Prior to iOS 10, it was kind of complicated and a lot of boilerplate and error prone. So hopefully if you're going to use core data, you can use iOS 10 and forward and not use, I would recommend trying not to use iOS 9 and before.
Yeah, it's harder.
It's harder.
Yeah, I noticed the dramatic simplifications in iOS 10.
Yeah, yep, and we'll go through it. So so your persistent store coordinator connects to a persistent store. This is the actual mechanism that stores your data onto the disk, and then if you close the app or something happens, it's going to be there when you come back. And it can be SQLite, XML, in-memory, binary, but practically don't worry about anything besides SQLite for right now.
Mm-hmm.
So we got our full picture. We have our NS managed context up here, our cute dog context with our dogs. And we can say, okay, so we've added 4 dogs to our context, and we haven't called save on it yet. So it's just kind of sitting there in our managed object context, just hanging out. As soon as we call save on our context, it's going to then take these 5 dogs, talk to our coordinator, and say save them wherever. I don't care how you do it, just save them. And our coordinator knows where to save them. So he's going to say, okay, save these dogs to the database. And you shut down the app and you come back a week later and you say, all right, I want those dogs back. I have a context. It would be empty at this point. It's going to say, fetch me those dogs to the coordinator. It will then go to the database, fetch them, and then populate the context with those dogs. So that's how that works. And this is just kind of a recap so you guys can see it again. We have our context with our objects, our coordinator, and then it coordinates with the actual storage mechanism. Core data versus NS keyed archiver. So this is kind of, it'll usually be pretty obvious that you want to use either NS user defaults or one of these 2 things, right? So when you say, okay, well, I have a bunch of objects, and now I have to figure out, do I want to use core data or NS keyed archiver? Kind of look down the list. Core data does entity modeling. You can query. It's pretty fast. You can have migration. So if your data model changes and all of a sudden we have like a tail length on our dog, we can do a migration of our database and basically add that row to our database. And there's an undo manager. NS keyed archiver doesn't have any of those things really. But what it does, here's the money shot though. Persist data, pain in the ass. And core data is a pain in the ass. So make sure you need it before you actually use it.
Yep.
So any questions before we get into the demo part?
If you have opinion as data like a modeling dependency, you have no choice.
Exactly. You're right.
Like
Yep.
my app has those dependencies, so I have no choice. Bad joke.
All right, let's see if we can get Xcode up here. Would you mind helping me out? Sorry, this is. That one, here's Xcode, and then you can just, okay,
Bring your
cool.
project
Thank
up.
you very much. Okay, so we're gonna make a really simple dog app, and please stop me if you have questions or ideas or whatever. Call it cute dogs. We're not gonna check core data. We're gonna keep it simple. We're gonna set it up ourselves so we understand what's going on. It's fine, okay, great. Okay, so we have so a couple things that we need to think through, right? We obviously need the pieces of the puzzle that we talked about last time. So we need a persistent store coordinator, a context, a model, and some entities, right? So we're gonna go through all those different pieces. And I usually like to start with the easiest stuff. So we're gonna start with creating that model. New file. And then down here is, okay, so when you, in the core data section, you can pick a data model. And a lot of times you're just gonna have one model. Like you can have 10 different entities in the same model. Usually I see people doing this. I'm just gonna call it model. So we now have a model with no entities in it, right? So there's not much we can do until we add something. So down here, so this is the visual editor for your model. So we have adding entities, adding attributes, editor style. So we're going to keep this real simple as we possibly can. We press add entity, and it adds an entity with the default name up here. We're going to change it to dog. And we're going to add a couple attributes. So to add an attribute, you can just go to this tab here, add an attribute, and we'll call the first one name. And then you have to pick which type of attribute it is, and you have a bunch of different choices. So the name will just be a string, and we'll have a max bark volume, and that can be an integer. All right, so that's the simplest possible thing we can do, right? One type of entity, no relationships. Over in our panel over here, we can see a little bit more information. We can see there's a couple different things. So you can decide if it's going to be optional or not. You can decide if it's indexed. If it's indexed, it takes a little bit longer to save and restore things. But if you're going to be querying on things, like if you're going to ask for a query of all dogs by name, adding an index will make that a little bit faster to query. It'll just be a little bit slower to save. But performance-wise, we're not really going to notice it. And then you can do things, well, we won't get bogged down in the details for now. Okay, so we have our model, we have our entity, and now we're going to add a subclass called dog. Actually, one thing first. Sorry. We're going to pick, I can't even see this.
Top is
Manual. Yeah, I want to do everything by hand. So Xcode tries to be helpful, and it does things like add manage object subclasses for you. But for now, I'm just going to pick, I'm going to say basically take the training wheels off. We're just going to do it ourselves so we see how it all works.
Yeah.
All right.
First time, it's good to do it
Yeah.
manual.
And then we're just going to go ahead and we're going to create a class called dog. And the class name should match with the entity name. NS managed, wait. Wait a second. Oh, maybe it won't automatically do that? Let me see. All right, whatever. We'll just create a, doesn't matter. Let's just create an NS object for now. And we'll call it dog. So this is going to,
I just don't know if you want to do a presentation mode for the font. So
yeah.
You can see the code. So just
Thank you.
Command, comma, and then presentation large.
Oh, perfect. Yep. Okay.
Yeah, I can
Thanks.
see that.
Okay, so in order to let core data know that it's in charge of managing this dog, we're going to make this a subclass of NS managed object. Oh, okay. Yeah, we have to import core data. So all this core data stuff, you have to import.
Core data.
Yeah, you have to import core data. Sometimes I forget about that.
Is this HICapacity?
You here for the iOS meetup?
Um,
Or for HICapacity?
yeah.
Oh, right on. Yeah, yeah, we're just doing a iOS demonstration real quick.
Invalid redeclaration of dog. I know what's going on here. It's because of this. Let's try everybody's favorite tricks of cleaning and okay. Let's try this one more time.
Invalid. So duplicate has been made.
Okay, so we're good. So now we have the dog. Now we have to match our our variables here to the to the attributes. Why? Okay. All right. Well, we'll just go with their version for now. So let me get rid of this thing.
Oh, it generate.
Yeah.
Is it your
It's,
dog?
it will generate it for you. So we'll just take a look at how Xcode does it for us. You get two variables with the same type that we set up in the visual editor. So you have max spark volume and name, and this NS managed prefix tells the system that, again, the core data is responsible for managing these attributes for you.
Yep.
All right. So now we're going to set up the stack. And the stack basically means the default, we want to get a reference to a persistent store coordinator, and we want to get a reference to the context. And as of iOS 10, it is easier to do that.
Much easier.
Very much easier. And I don't like all this boilerplate that this gives you. Just get rid of this crap because you don't need it. Until you need it, get rid of it. Okay, so right when your app starts, an application did finish launching with options. First of all, we have to import core data. All right, so we need to create something called a persistent container. So persistent container, I'm probably gonna make spelling mistakes. We can fix them or not fix them. And that's persistent. Persistent container. Okay, so this is going to give us something called a container. And then you just simply pass the name of your model here. And our model is named model. You don't have to worry about the X, the suffix to it. And then once we have our persistent container, we can go ahead and we can get a reference to our context. So we can say persistent container dot load persistent store. Oh, I'm sure that's not spelled right. Yeah. I know. Persistent stores. Okay. I was hoping to get a little help from. Yeah, I have a hard time.
No, sometimes sometimes it takes a while for.
Can you hit the escape key? Problem with the
Yeah.
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 Exactly.
So I have to run, but I have a one comment question about what you're talking about. So as a company, we've done a few projects with Objective-C in the past. Core data in the past, and it's been a real pain for some things. Recently, we switched to Realm for a lot of things, and but I just want to point out the ups and downs for using Realm. So it's like a pretty popular toolkit for storing data, and it is actually faster to write data to the database.
Yeah.
However, the trade-off is it makes your bundle size about 4 megabytes bigger. So that's what. But it's pretty much better in every way for the coder.
Yeah.
It's much easier to use. But anyway, that's the only thing I wanted to share.
Great.
But yeah, thanks for doing the presentation.
Yeah, my pleasure.
Good content. It's good stuff.
Yep.
CJ.
See you, James.
All right. Okay, so we'll have a closure here. And we'll have okay, so we're gonna make sure we don't have for now, if we have an error, we're just gonna bail. Okay, all right, back on track. Sorry about that, guys. And then we need to get back out onto, so this is happening on a, it's crazy how little you know without code completion.
Yeah, right.
You know, like the little
Yeah.
details of things. So this is happening on a background thread. So basically we just need to jump onto the main thread. So we're gonna go dispatch queue. And async. And right now, so we're going to let our context equal persistent container dot view context. So this is how we get things going here. Let's see if that goes. All right, sweet. So basically what you do is you create this thing called a persistent container, and you call load persistent stores off of that.
Right.
And inside of the completion handler, persistent container will then have a context for you that you can use throughout the app.
Right.
And I've seen people manage their context in different ways. The way that Apple recommends and the way I like to do it is to use what's called dependency injection. So you create this thing in the very beginning, and as different view controllers need the context, we're going to pass it along to those view controllers.
Yeah, makes
All
sense.
right. So in our first view controller here, we're going to make a property.
Manage.
And again, yeah, we'll just get rid of this crap for now. And because we're going to be using anything related to core data, we need to import core data here. And we're going to have a property of managed object context. I'll type ns managed object context. We'll just, okay, great. And all right, so back in our app delegate, since that view controller is our first view controller, we are going to then do this. We're going to say let storyboard equal storyboard, a UI storyboard. And, it's just main, I think, right?
Yep.
And then bundle is nil. And then we're going to say let view controller equal storyboard dot, oh boy, spelling instantiate without code completion.
It is a little challenging.
Instantiate view controller with identifier.
Yep.
And then we'll have to give that one an identifier. So basically we're going to just get a reference to this view controller and we're going to create it from get a reference to it from our app delegate.
I just want to give you a heads up. 10 minutes till 7. I'm happy if you go over.
Okay.
Yeah.
VC1. I'll just call it VC1 for now. Normally you'd have a more descriptive name here, but we're just trying to make this a little faster. So VC1.
Just had a quick follow-up question on that one. So you just set the name as VC1. Do you need to click the checkbox for use storyboard ID?
No, so this is for the restoration ID.
Oh, okay.
So if you want the storyboard, if you want to use your restoration ID to be the same as your storyboard ID, then you click this and it fills it in for you.
Oh, okay.
Yeah.
Yeah.
It's confusing. I didn't know what it did for the longest time.
I still don't really know what restoration ID does. I guess it's just a view controller navigation back and forth.
It kind of goes along with persistence. Like if you want to be able to recreate the state of your app, you can have your view controllers all recreate themselves in the state that they were when something was saved.
Oh, wow.
Yeah,
Okay.
like if you get killed.
Okay.
Yeah. I've never used it because it's a huge pain in the butt, but I know it's possible. And then we're going to cast this as, it's currently just called view controller, and that's good enough for now. Guard. Else again, we will just crash if we somehow screw that up so we know what's going on. Okay, so now we have a reference to our view controller, and now we can set the manage object context finally. So we'll say view controller dot managed object context equals context. And the reason, so view controllers don't normally have this property. It only has it because we went ahead and we set it right here, and it's public. So now when this view controller loads, we'll have a reference to the manage object context that we can then use to work with core data. Okay, so what we're going to do is we're going to add a dog's name in this first view controller here. So we're going to get a text field, and why don't we wrap this thing in a navigation controller while we're at it. Okay, so we can add the name of our dog, and then we can have a button to say add dog or something. Okay, and we're going to option click to our view controller, and we're gonna hook these two up. So we're gonna have this is our dog name text field, and this is our add dog button. We're gonna make an action for this. And we'll say handle add dog button was tapped. Okay, so when this is tapped, what we want to do is we want to grab the name that was in the text field. So we'll say guard let name equals dog name text field dot text, else return. So we want to just make sure there's something in there, and then we can say now we're going to actually create our NS managed object, and this is a little funky, so you got to kind of follow along with this one. We're going to say guard. Wait, we can close this up and get some more real estate here. And there are wrappers to make this easier, but I want you guys to see how you actually do it.
Absolutely.
Yeah.
Dog equal, and then NS entity description. Then you say insert new object for entity name. And our entity name is dog. Into, and so which context do we want to insert this into? We want to insert it into our managed object context. Yeah. Oh, okay. And then also this returns this, and we want to make sure, we want to downcast to make sure that it's actually a dog that it's creating. Else, again, now we'll just bomb out. We'll say fatal error if something goes wrong. So we're saying with this name, give us a dog. And then we have to set the properties on the dog. There's not like an initializer where you can say create the NS managed object and insert all of the different attributes. You actually have to create the thing and then add the attributes on later. So we can say dog dot name equals name, and there we go. That's it. So we're not getting the max bark volume right now, so we will just leave that off. That's an optional field. And the way we save it is we want to save the managed object context. We don't save the dog, we save the context. So we could have inserted 4 dogs, could have inserted 4, deleted 1, changed the name, and you save the whole wrapper and it does everything at once.
Yeah. Oh, I see. It's not just one object, but the whole context.
The whole context gets,
It belongs. Okay, that makes sense. It's more efficient that way.
yeah. And it's just that.
Yeah.
And then let's just, at that point, let's just take that dog name text field, dot text, and then let's just set that back to okay, so this can throw. So if you were doing a real application, you would want to actually catch the possibility that it could have an error, but we're just going to try. We're going to force try it. So if this fails, whatever, it's just going to crash. So we have a lot of places right now in a production application, you wouldn't do these things. Like you wouldn't have all these fatal errors running around. You'd want to handle the problems. But for tonight, we just want to see how the API works. So we're just basically crashing everywhere if it didn't work. All right, let's try to run it. And I know we're probably running late, so if anybody has to go, I won't be offended. Just go for it. So it's the app is starting up. Application did finish launching with options. It's going to run. Go into the background, create the context for us. And then as soon as we have that context, we're then going to instantiate this first view controller and pass that context along to it so it has it. So every view controller isn't having to make its own context.
Makes sense.
Let's see. I see this. How do I get you guys to see this?
Yeah, straight up. Not sure why it won't move on. Should be right up above. Not really sure
Okay.
how to get it up there.
So, well, I mean, as you guys can imagine, it looks just like the storyboard. There is a, yeah, okay. So unfortunately, we're not able to get.
Oh, you know what I think it is? It's the full screen on the X.
Oh, right.
Just gotta get out of there. I think that's what it is.
That would make sense. Yep.
There we go.
All right. So we're gonna say Fido, and then we're gonna click Add Dog, and we're gonna see if we break anything. Yep. Let's see what we broke.
Fatal error. Unexpectedly found no nail one.
Manage object context. Insert new for entity name dog into manage object context as dog.
That was fatal error.
Okay. I wonder if there is a print managed object context. Let's see if there is a managed object context. Okay, we click our button. Okay, so there is, what is going on with our managed object context? That's what we'll figure out. So, oh, I think I know what it is, guys.
What happened?
I didn't finish this part of the, okay, so we set the managed object, so we're back in the application delegate. We're on, we've got a reference to our first view controller. We've added the managed object context to it, but now we have to do a couple more things. So we're going to say let navigation controller equal UI navigation.
Oh, okay.
Root. And our root view controller is going to be our new view controller. And then we're going to make this view controller the root window. That's what we were doing properly, right? So we're going to say self.window.root view controller equals nav. Okay, so before we were getting a reference to this view controller, but we weren't actually setting that as the root view controller on the window, so it wasn't. That's why it didn't have a context.
Okay. Oh, yeah. Okay, that makes sense.
Okay, let's put in our dog name again. Okay, great. So that saved it to core data. Now let's quickly get it out of core data on one more screen, and then that'll be good for today. I can definitely answer questions or kind of work with people if they have questions later if they're trying to use this. But let's just get one more screen. And we will add a way to get to the next screen. Put it up in the navigation controller. We'll make a segue, and we will show it. All right. All right, so yeah, we'll keep this really, really simple for now. We'll make a UI view controller. We'll call it show dog. Up in our storyboard, we're going to say make this show dog view controller. And then in show dog, we're just going to have a label that has the dog's name. So we'll get a reference to that label, and we'll call it the dog name label. All right. Okay, and again, because we're going to be dealing with core data here, okay, core data, var managed object context, again is an NS managed object context. So this is another example of what's called dependency injection. So rather than, again, trying to come up with this managed object context, we are passing it in.
I'm curious on this one, Adam. So you're putting this one outside of the class versus the other one?
Nope, yeah, that was a mistake, thank you.
Oh yeah, it has to be within the class.
Yep. So this will be kind of an arbitrary example, but I'll explain why in a second, but that's okay. So what we're going to do here, okay, let's set up the other view controller to pass it over. So
Oh yeah, you do that in the segue.
exactly, yep. Prepare. It's not going to help me, is it?
If you need escape, it might give you some code completion. There we go.
Yeah, prepare for segue. Yeah, so there you just.
Prepare for segue. So usually you would check the name of the segue, but here we're just going to prepare for segue. We're just going to assume it's doing the right segue. And we're going to say guard let show dog view controller equals segue dot destination. Okay. I didn't know about that escape trick.
Yeah.
Yeah, okay, usually it just shows up.
This is a slow computer.
Yep, that's awesome. As show dog escape. Come on, don't fail me now. Yep, that's it. Else fail error.
Love my favorite.
Okay, so now we have a reference to that thing, and now we're just going to set the manage object context that we have onto this show dog view controller. Let's make sure that's right. Is that right? Yeah. So that has a manage object context. Here. Object context equals our managed
Object context.
object context. So this is what dependency injection means.
Oh, yeah, doing all of that.
So basically what's happening here is before the segue actually triggers to go to the next screen,
You're doing all the prep.
we're doing the prep work. So we're getting a reference to our next view controller, and we're passing along the manage object context, which knows about saving and deleting and fetching dogs. Okay, so
So you can basically pass from the original root, you can pass it to anywhere, and you can pass it back and forth.
Exactly.
Which, yeah, that's what I've been doing in the app.
great.
So
Yep.
yeah, I know about the dependency injection. Very useful
Yeah.
for passing objects back and forth.
Okay, so now when the view loads over here in our, we want to create what's called a fetch request. So we want to be able to fetch a entity from core data. So the way we do that is we create a fetch request equals ns fetched. Request. Yep, and then we tell it what type it's going to be. So it's going to be a dog. And then we just give it the entity name. And we say it's going to this is the entity type. So we're going to create a fetch request for dog. We then go ahead and say, and it's going to give us all the dogs back. So it doesn't know if there's 1 or if there's 100 in there right now.
Right.
Okay. So we're going to say, let dogs equal, again, we're going to try managed object context dot fetch. And what are we going to fetch? We're going to use this fetch request object that we made up above here. So you create a fetch request, and then you tell your manage object context, go fetch me what I just told you to grab in this line up here. So this is going to pass back an array of dogs. It could be 0, 1, or 100.
Is it wrapped in anything, or is it just going to be?
It'll just be an array of dogs.
Right on.
Yeah. So this is really useful if it's a table view, right? Like we could say, give me a table view
Or collection view.
or collection view, anything like that. In this particular case, we had a dog, so we could have just gone ahead and just passed the dog along with dependency injection. But this is like an example, right?
Yeah.
So we're going to say, give me the first dog in this array equal dogs dot first, I think. Yep. And that'll give us an optional dog. And then let's just set that label equal to the dog's name. So dog name label dot text equals first dog dot name. Okay, we'll get rid of this because this is just noise. Yeah, we'll say if let dog, just in case there's not one. Okay. Actually, this is great. Yeah. Well, come on, baby. Let's go. What is this?
No. Sometimes it takes a while.
Okay.
Yeah.
So obviously we've closed the app. That first dog we created a while ago, Fido2, is totally out of memory, right?
Mm-hmm.
We're not going to add another dog right now, but we're going to go to the next screen by tapping this.
Nice.
And it's going to show up here. So it persisted the data across multiple things.
Mm-hmm.
So that's the essence of it. But what we've done here, you could still have done with just NSKeyed archiver, right? Which would have been a lot simpler. So we're just going to add one more piece to it, and we're going to add a predicate. And a predicate basically means, here's some rules. When you're doing your fetch, I want you to follow these rules. So I want it to
Exactly.
start with the letter F, or I want the max bark volume to be over 20, and only return those NSManaged objects that conform, or that conform to my predicate. So it's really simple. Let predicate equal NS predicate. And this takes a little while to get used to, but NS predicates are used throughout iOS development, so it's worth learning about. Okay, so let's just simply say name contains, it's kind of like SQL, you capitalize this, and then you put in one of these guys, and then whatever we want it to be over here. So anything that contains Fido,
Right.
put it in, so you put that over here. So give me, here's a predicate, the name attribute that contains Fido is the only things I want returned.
Right.
And then what you do, all you have to do is you take your fetch request dot predicate equals predicate, right? So we're adding, so this fetch request has a predicate property, and you just add a predicate to it.
And the predicate property is optional, right?
It is, Optional, yes, exactly.
Because you may not have a predicate.
Yeah. So we'll call it Benji. So right now, we know we've added one called Fido, and we've seen it come up. But if we add this predicate, there are no Benjis, so we would suspect that nothing's going to come up. But let's check it out. And this is where the power of core data starts to come in, where you can make these more and more complicated things. Like,
Matching multiple predicates.
yeah, so we're going to go over here, and
Yep.
nothing happens. So now we're going to come back, and we're going to add Benji 1. We're going to add this to core data. We'll go to the next screen, and then there it is. It's got Benji. So now you can start to see where the power of this comes in. Yeah. And that's pretty much my talk. I'd be more than happy to answer any questions or follow up with you guys.
Does anyone have any questions? That was a really well thought out presentation, especially going from NS user defaults all the way through to core data. So
Thanks.
thank you so much for
Oh,
putting
my
this
pleasure.
together.
My pleasure.
It was
Yeah.
well paced. Everything. I mean, you know how it makes sense while you're getting it, right?
Yeah.
I'll be looking through this.
Cool. Great.
Great. Thanks, Adam.
Yeah, you're welcome.
Yep.
Did anyone have any questions? Okay. I'm sure you'll get some questions. in the
Yeah,
messages
yeah.
and stuff like that.
Feel free, guys.
Thanks a lot, Adam.
Thanks.
Okay, so I guess that concludes the 23rd meetup, and I think we're gonna work on some of the sorting stuff. Do you, O'Neill?
Yeah.
All right, that's good. Thanks, Adam.
Thanks.
We're stopping the stream now.